Okay, and we are live. Hi, everyone. Thank you so much for joining another VJX session. And here with me, we have Philip from Elasticsearch. Hi, Philip. How are you?
Hi, good. How are you?
Awesome. Thank you so much for joining us today. We're very excited to have you here with us. It's our first time. It's your first time here on the VJX, right?
It is. Hopefully not the last one. Let's see.
Yeah, hopefully. And as usually, we tell our people that are on our live audience, you can join our Slack channel and you can post your live questions over there. So if you want to go to our Slack channel, please go to our website called virtualjug.com and you'll find the link over there right on the top corner. You have something say join VJug and then join Slack, and they'll give you an invite link to join our Slack channel. So join over there. There is a live session channel. I'll be there monitoring, and if you want to post any questions back to Philip, I'll be monitoring that, and I'll relay back any questions that you have to Philip. So without any further delay, I'm gonna give you control back to you, Philip. So feel free to start whenever you want.
Sure. Let's start with the screen sharing. Does it look like you have slides?
Yes.
Very good.
Wonderful.
Well, no worries. I only have a few slides. Let's quickly see how you could monitor your Java applications with the Elastic Stack. So this is kind of like a very famous tweet, which I really like, that once you have more of a distributed application, everything gets more like a murder mystery. And unless you really like to have these murder mysteries and you try to piece little informations here and there together to see what is going on, you really want to have some central place to see what is really going on in your system. And that's really the idea of what we want to do. So we want to have an application that is maybe distributed, could also be centralized. We just want to see what is going on in the entire application and like monitor it for performance and errors and just see what is happening in your application. So that's the general idea of what we want to do. And oftentimes we have an application and we're sitting in the middle of it, and half of it around is fire, and we say, well, this is fine. And every so long, everything is fine until at some point, nothing is fine anymore. And we basically want to avoid the bottom half where you can see here, everything is on fire. What the hell is my problem? We don't want to get to that point. That's kind of the idea of where we want to end up. So we want to log, monitor, ping, trace, all the things. So we generally want to just get an overview of what our system and our application is up to. So that's the overall idea here. Maybe you're already using the infamous ELK stack for logging, Elasticsearch, Logstash, Kibana. So you have Elasticsearch, which stores your data, which could also be full text search. We have Logstash to get your data and parse it and enrich it. When I say enrichment, people are sometimes kind of confused. Enrichment could be, for example, I have an IP address and I do a geo IP lookup, so I know where an IP address is coming from. That would be enrichment here, for example. And then we have Kibana to visualize the entire thing. And then, well, that in combination gives you ELK. And we even have this ELK as the logo here. And that worked very well until at some point we added another component called Beats. And Beats is like a lightweight agent or shipper. And that takes over more functionality than what Logstash has been doing. And we'll cover a lot of ground with the Beats today, actually. And the problem here is there is no B in ELK. So we tried to come up with something we call the ELK B or BELK. And it could look like something like this. So you can see it's a B and it has the ELK horns. However, we didn't really go with that in the long run because, well, it's not really scalable, and we always strive for scalability. Because what would happen if we add another logo here or another product? We would get another letter, and then we would need to make up another animal, and it would get very confusing. And regardless of whatever that letter would be, it might take us quite a while to figure out another animal. So we've kind of gotten rid of that, and we now just call it the Elastic Stack. And that's why we generally speak about Elastic Stack. But if you say ELK, we'll still understand, and we get the idea of what you want to do and where we want to go. And everything I'm showing you today is open source, so actually Apache licensed with some minor pieces which are freely available, but not open source, but open code. And you can just take what I'm showing you and go crazy. So why am I talking about that? I work for Elastic, the company behind that. So I know our stack pretty well. And well, today we'll just take a Java application to see how we can put that into action and put all the pieces together to make them work for you. It's, well, not a full application. It's more like a Hello World application, but you get to see a lot of monitoring pieces and how they play together. So I generally build like very highly monitored Hello World applications, and today is no exception. You will get all the code at the end, and then you can just try that and go wild yourself. So let's imagine this is my CEO. Your CEO storms into the office and says, like, the application is down, and you need to figure out what is the problem. And all hell is breaking loose. Nobody knows the application, and you have no real idea what is happening. Luckily, we think we have deployed the Elastic Stack to monitor the application. So let's see what is actually happening in our application. And that's it for the slides. Let's jump over and do something live. So we know we have our application, and our application is monitoring to the Elastic Stack. So we have Kibana to actually see what is happening. And if you've never seen Kibana, this is Kibana in the current version. So this one is a bit more blue. The previous version was more colorful. Before that one was white, and the one before was black. So depending on how it looks like, you can already see which version you have. But the version doesn't really matter that much today. Let's see what is going on. So our CEO has stormed in and said the application is down. And well, we don't really know what the application is or what we have. So luckily, the stack has some monitoring components. Let's quickly head over to those monitoring components so we can generally see what we even have in our stack. Let's assume you don't know anything of what we have running here. And that's kind of the trick here. I'm not showing you what we have or where this is running. We will figure this out as we go along. So let's see. We have Elasticsearch, which is storing some data. You can see we don't have too much data yet. We have 7 gigs of logs. We have 13 million or so events collected. We'll dive into those a bit more. You can see we have Kibana, so we can check out what is going on. We have beats. And here in the beats, you can already see we have 9 beats running. And we have 5 different beats here, which we are using today to monitor stuff. So we'll stumble or use all of those over time. Audit beat is generally for security events. It's like auditing. Metric beat could be system metrics or application metrics. We'll, for example, see GMX metrics and how to get to those. Then we have packet beat, which is, well, network layer. File beat for logs, and heartbeat, which is basically the pinger to see if our application is up or down. So the very first thing I probably should do is I should check, like, what is heartbeat doing? Like, what is my application up to? We have a pre-built dashboard for that. So heartbeat is basically one agent that is just pinging my application, and we have a dashboard afterwards which shows us what our application is up to. So let's head over to heartbeat here. Luckily, that one is already open. You can see here, something here seems to be down. And you can see in this graphics already, we have something in the backend which has a health endpoint. That is unfortunately down. We have various other components here which seem mostly up, so those are fine. We're not too concerned about those, but our backend application right now is down. And that's not really what we want. By the way, just to show you, you can also see with that pinger, it can ping TCP, ICMP, and HTTP, HTTPS. So it can figure out stuff that is down, for example. So here, this red stuff, this is the thing that is down. You could also see response times. For example, if something suddenly is very slow, you could see what is the response time and also where are you spending your time. You can see how long does it take to resolve the host, establish the TCP connection, establish the HTTP connection, and then do the TLS handshake. Here you can see this is the TLS handshake that is happening in the middle. And you could, for example, see also the latency histogram. But latency is not really the heat map of the latency. That one is not really that important right now because, well, something is down. Something in our application is down. So where should we start? Roberto, where would you start to monitor the application? And this is not scripted, so let's see. Any guesses, Roberto, where you want to start?
Okay, so let me see.
Not just in general.
Okay.
Like where would you go once you see something is down?
Well, I'm probably gonna try to go to that web link and see what's happening, right?
No, sorry. I was more like into like, should we go to the logs or should we see how the system
okay.
is doing?
So yeah, so usually if I see something is down, I'm probably gonna try to, if I have like some kind of health check, I'm gonna try to check that out, or maybe I'm gonna try to see some logs and see if the server is up or down. Hopefully you guys have some kind of a monitoring tool that tells me if and I'm pretty assuming that that's a health check coming back from our app.
Let's see.
And probably gonna SSH that box and see if that's
we could,
running over there.
But that's not really the fun part. Like let's leave out SSH. Like my enemy here is basically SSH, because, well, as soon as you have many containers or many hosts, SSHing is not going to scale really that well anymore.
Right.
Let's have a look at like the actual events here. So here, this one here, so these were the pre-built dashboards. I didn't build those myself. I'm lazy, and you can be too. These are I'm just using those. So here I'm heading over to Discover. Discover are basically the raw events. And while we will jump into the logs in a minute, let's look at the raw events that we have from the heartbeat. So for example, here you can see it's very stable. We have our pinger running. It's just pinging services to see what is up or down. And you can see here we have collected a lot of information. For example, you could see here we're pinging something on HTTPS on some specific host. That is actually the tracing collector. We'll see that later on. But the one thing that I'm interested in now is, let's say, I'm only interested in the stuff that is down. And we have this monitor status here, which is currently up. So let's say we want to exclude everything that is up, which will basically leave us with everything that is down. So if I click on that minus magnifying glass, which might not be super intuitive, but if I click on that, it will exclude everything that is up. And now we have fewer events, and we see which ones are down. So if I open those up, you can see we have the backend application here. That one is something timed out, so that is not doing so well. We could actually, by the way, go there. So if we hit backend WPF/health, this doesn't seem to be very happy. This will time out at some point, and you can see this is down. So something on HTTPS is down. If I open the next one, you see, oh, this is something with TCP. And if you scroll further down, you can see, oh, this is actually MySQL. So MySQL seems to be down as well. So we have a pinger that is pinging HTTP and TCP. Here we are trying to connect to the MySQL data store, and the MySQL data store seems to be down, which, well, that's no good. There are multiple ways you could figure out what is happening now. By the way, one nice thing is, once you know, for example, what you're looking for here is, with all these events, since this is just based on search, you could just like type MySQL to see like how is MySQL doing. And then, for example, you could say, okay, you have down here. If you click on this one here, it will pull out the column. Let's fold that in again. And then you can see here, these are all my events, and MySQL is just down right now. That's no good, and that's also why our application is failing. So we could probably see that in the logs as well. So here my application seems to be down. No good. So let's see. Let's head over to the logs next. So I'm not interested in the MySQL logs. What I'm interested in here is we have a lot of events here. We don't have a monitoring status, so we can throw that away. You can see here, this is actually lucky. Here you can see we tried to establish a JDBC connection, and this is not working as expected. You can see it's a warning. We have a full stack trace, like my application is down, and you don't really know what is going on. So I have a lot of logs from different things here. Something that might be interesting is we have this application Java, and I could just press that plus sign here and just filter down on those log events. You could also do that in a bit more structured format, when here you could just say application is Java, And then it will filter down from, I don't know how many 1,000 events we had before, to my 123 events we have right now. So you can see here, these are basically the logs that we have collected from my application. So this is down. And we've now established that probably MySQL is down. So now I will actually SSH into the box, or I have SSH into the box, because what I've done before is I've stopped the database. Hopefully it was clear that this was the problem so far. We are restarting MySQL. We could also, by the way, figure out that we have stopped the database manually. That is what we would have in the auditing events. If we have time at the end, we can come back to that and actually check who or which users stopped MySQL here to figure out maybe somebody has broken into your system and changed something. But let's start the application, or let's start MySQL or restart MySQL. Hopefully my application will recover. Now it's up. So this looks better. And let's see if what my application is actually doing. By the way, this is an online application. Anybody listening can generate the request, and we'll actually be monitoring all the requests that you're sending. For the domain, did anybody figure out how I came up with this? This is also my Twitter handle. Did anybody figure out from the very first slide how we ended up with that name? So if you open that one here, and if you take my last name, it's a rod13 where you rotate the letters of my last name by 13. And this is how you get to my Twitter handle. The nice thing is about rod13, you rotate by 13 again, and you're back at the original, because 26 letters in the alphabet. So that's why I use that domain. And since this is a demo, I always think WTF for a demo is kind of the right thing to use. So now my application should be up and running again. So for example, I could add 10 random people. This will need the MySQL database. So now my application should be fine again, and my CEO should be happier. We can go back and, for example, search for everybody in my database. And then we would see, okay, we have obviously somebody clicked a bit around as well, and now we have 66 people in my data store. And it will only get more. You can click on any link, like some are giving you 500s. We want to monitor those anyway. Some give you a 200 with a parameter. For example, here in the URL, you have a name. You could just, for example, say, oh, I want to use an emoji. And we'll log all of those as well. So everything we will cover later on and see what has been happening here. So to look a little behind the scenes, let's take a look. We've looked at heartbeat so far. Let me quickly show you the heartbeat configuration of what I've used here to actually monitor my system. So here, it's one of the beats. It's written in Go. You have a native binary. You just run the binary to check. For example, here, you can see I'm checking that my front-end application and my back-end application are up and running. They're being pinged every 10 seconds with a 3-second timeout, and we expect the 200 to come back. If they're not giving you a 200 back, the application will be marked down. We also monitor Kibana and Elasticsearch itself, which doesn't make too much sense for Elasticsearch, because when Elasticsearch is down, we wouldn't be able to store that event in the same Elasticsearch instance. So you would probably, for production, want the dedicated monitoring cluster. But here for our demo, it's fine. And here, this one here, you can see this is where we monitored MySQL. So this one is the TCP connection on my MySQL server on the default port, also every 10 seconds. And here we're adding a name. That was why I could search for MySQL in the heartbeats and just figure out what is related to MySQL. And then we're just taking that and storing that into Elasticsearch. So that was the heartbeat thing. And there we could see what is happening in our application. For the logs that we have seen so far, how would we collect the logs? So probably the good old way how you would collect logs is, let's head to my Spring application, my logback configuration here. Probably you would have some classic log file how you would log. And that works. But I'm lazy and I don't want to parse this file, because what you would get is the classical log file where you would have the log level and the timestamp and the log message, and I have MDC information, and I have all kinds of things in that thing. And I would need to write a regular expression to parse that back. Who likes writing regular expressions?
No one.
Yeah, very few. And everybody who says they do, I would normally say this is the Stockholm syndrome, where you just got so used to doing that that you accepted that this is how things are. But this is maybe not what we want. So I said I'm lazy. So what I'm doing instead is I'm logging to JSON. So we have this logback appender for JSON. I'm just adding that, and then I can say this is actually what I want to store as JSON. And since this is a JSON output for my logs, and Elasticsearch is storing JSON as well, the FiveBit, which collects the log files, doesn't need to do any parsing, and we don't need logstash in that example. We just tail that JSON file basically and store that in Elasticsearch, and that's where all our log events end up. So coming back to our logs, let's see what we have. So this is the log file, and this is what we have been collecting. And by the way, this here is the configuration for that. So in this line is the one where I basically say, we have a JSON log file, I want to tail it, and then I want to store it in Elasticsearch. Also, I say, this is a Java application. This is useful because I'm collecting all kinds of logs here, like Nginx and system logs and MySQL logs. But if I want to only drill down into my Java application, for example, this is what you could filter on. And then you could see that this application, Java, this is how I could just see the logs from my Java application. And if I refresh that, since you probably have generated more log events now, you can see here you were generating more requests, and this is when we were getting more events. So this is working nicely, and this Discover view has been around for a long time. You see, I see the last 15 minutes, and I could enable auto refresh, which would refresh this page every 5 seconds. But sometimes you want a bit more. Sometimes you want something that is more closer to tail F. And what you could do here is we have a dedicated UI for that, which is called the Logs UI, which has, well, this logo here. In a Logs UI, you could just see all the log events that happen in the system that you're monitoring. So here you can see, for example, here I had my MySQL failures. You could just say, I want to have a stream, and I want to see everything that is happening. However, this is not just my Java application. This is other stuff, if I didn't have that. So you can see here, these are, for example, this is a MySQL log. And then this one here is an Nginx log. You can totally filter down on that, and this will keep updating and refreshing all the time. This is really like tailf, which just from as many containers or servers as you have, will just live tail all of those events that are, or logs that are happening there. And I can see everybody who is trying something, then we're getting more exceptions. We could totally filter that down. So for example, here, since we know we have this application, and that one is called Java, and the UI is luckily guiding me through that, I'll just filter down on that. And now I'm just getting the calls to, or the logs from my Java application. You could also say, for example, I only want, there is a service, and there is a service name. And then we could, for example, say, I'm only interested in my front end or my backend application. I only have 2 services right now, but you might have many more services. And that's where you could just drill into, like, let's see only the front end events. And now we're just getting all the events that are happening in my front end application. And you can just keep streaming your logs and see what is happening. That way you can figure out how your application is potentially doing. You could, by the way, also get a bit of an overview of what you have infrastructure-wise. So we have this infrastructure UI, which shows you, for example, how many hosts I have. So I just have 2 cloud instances that I'm monitoring here. You could say, right now you see the memory usage. We could see, I don't know, the inbound network traffic. And you can see here, one instance is serving much more traffic than the other one. Or you could see the CPU usage. If you had containers or Docker, you would see that broken up as well. And this view will scale very well to hundreds of containers or pods, for example. And you can also group that, for example, by pod name, Kubernetes namespace, Docker name. Here, since I'm running on the AWS, I only have availability zone and like the machine type. You can see, for example, I'm running in the EU data center, and I'm running in A and B, and I'm just seeing how my instances are doing there. This view can accommodate hundreds of instances, and you can just click on one, and then say, oh, I'm interested in the logs of this specific event. Or I want to see like, how are the metrics of this one? For example, if I click into that, you can see like, how are we doing resource-wise on that instance, which wasn't the problem here, but you could just see like, maybe at some point your resources are running out on an instance and you want to see like, how has that developed over time? So you can see CPU, load, memory usage, that all looks pretty good, or networking usage, how my instance is doing. So this is just how we collect it. And this is metric beat. So here you can see we're getting metrics from our application. So this is working fine. What else would you want to see? So for example, since this is a Java application, something we might be interested in is the heap. How would you collect the heap?
Well, most of the time you have to do like a thread dump.
Yeah, the heap usage. However, there is also in Spring Boot the actuator endpoint, which is the JSON. So if you had two metrics, and then it will, now with the new way, it will show you just which metrics are available. And then we could, somewhere we will have JVM, GC, do we have heap somewhere? Or not in this one. But we can see, for example, the memory max usage. Here you would see information about your Java application, and you could just get metrics out of that. And metric beat can get metrics, and it can get those in two different ways. So one way would be we could just collect that endpoint and just go to whatever metrics, JVM, memory max, and collect that is a JSON document, so we can just store the JSON document. Or we also support JMX through Jolokia. So basically we have the metric beat configuration, which I haven't shown you before. Let's quickly look into that. So for example, here you saw like the CPU and memory load. That was what we collected with the system module. We'll get into MySQL and other things as well. Here I'm basically saying this is the JSON endpoint that I want to collect to get the metrics via HTTP. Or since we support Jolokia, you can see this is, well, the typical MBean configuration of that I want to collect, for example, like what is my application doing memory-wise. And now I would want to visualize how is the heap doing of my application, or how much heap am I even using. For this one here, we don't have a pre-built visualization yet. But what we can do is we can build a visualization ourselves. And let's quickly try that out as well. So there are lots of visualizations that you could build. I want to use that visual builder, which is kind of, if you have like time series data, this is pretty advanced to show you what your application is up to. By default, it will show you the number of documents. So you can see here we collected that many log events. Let's see, the first thing that I'm interested in is I don't want log files, I want metrics. So I need to switch this over to metric beat. And then I don't want to have the count of the documents, but I want to have the sum of the heap usage. So we have, since this is Jolokia, you can see heap usage used. That sounds good. And if you see up here, now we see the heap usage. But that's a very large number, and it's very hard to read what is going on. So the first thing I want to do is, this is not a number, this is bytes. And if you look into that now, you can see this is how much heap I'm using. However, right now, this is aggregated over all my instances, and I have 2 instances. So let's break that up on a per instance level. So right now, this is grouped together everything. What I want to do is I want to break this up into terms and say in beat.name, I have application name. And then you can see how is my heap usage developing. And you can see my front end and my back-end application is, they're doing okay. But I'm not really sure how much heap do I have in total. So maybe what I would be interested in here is how much % of my heap am I using? So how would I go about that? Luckily, we don't just have the sum of the heap usage used. We can say, I want to add another metric. And this one is the maximum of the max heap usage. So go look here, heap usage max. this is basically the maximum of the heap. And you can see this is 371 megs per instance. And now I can add a calculation, which is kind of the third step. That one is called math. What I'm doing here is now I need to take those two calculations that I've done before and add them into a variable. So I take this one is the used one. Let's call that variable used. So we map that to the sum here, which we've defined up here. And then let's define the max. And this one is the max. And now I can say params.used. So this is exactly this variable here, divided by params.max. And this should show you how much of our heap we are using. But now again, this is not bytes, and the 0.12b doesn't make much sense. What we want to do here now is, this is not bytes, this is percent. And when I switch it over to percent, you can see, this is how much heap we're using in our application. So you can see 20% or so of our heap is being used. So that is pretty fine. And you can also see like garbage collection, more garbage is accumulating, you have another garbage collection, more garbage is accumulating, etc. So you can see how your application is developing. One other thing that is sometimes nice is somebody changes something in your system, and then you run around the office and shout, who changed something? Who did something? Because something is suddenly broken. It could be you have more 500s, it could be your heap is suddenly larger, you have more CPU usage, and it would be nice if you could annotate any changed event in that graph here. And luckily we have these annotations here. And what I'm doing in the background is every time I change my application, I don't SSH into my box, but I use Ansible to change anything. And every time Ansible changes something in my application, like deploying a new version, it will write out an event also to Elasticsearch. And then I can use that event to show me who has done what at what point in time in my application. So you can add those annotations here. I've stored those in some index I call events. And if I remember the fields correctly, I think I have application, host, and user. So what you can do is you can say user, change application on host. Probably I haven't changed anything in the last 15 minutes. But let's say over the last 4 hours, did I deploy anything? And here you can see when I've changed something. So for example, here you can see I restarted the front-end application. Or you could see here, I changed the configuration on the backend and the front-end instance. And every time you change something, you could, for example, see here, I did something and suddenly the backend application was gone. So something happened here, and it's probably correlated to whatever you were running here. So you see any changed event, and you could, for example, also zoom into one event. So you can just mark it here. You can see here, I ran the restarted application, and suddenly the front-end application was gone because, well, this is just stopping the front-end application and then restarting it. But you can see here, it's basically missing, and you have the exact correlation. Somebody ran an Ansible script, changed something in the system, and you can directly see what has been happening in your system. Okay. So our application seems to be working okay now, but what about our users? How many users are coming to our system? Let's see how that is doing or how that is going. So there are two ways we could look into how many people are coming to our system. Let's start with PacketBeat for that. So PacketBeat is like, we're using the same library, libpcap. Who likes using Wireshark? Normally, Wireshark is when you're totally desperate, like you have no idea what you're doing anymore. So what you're doing is you start Wireshark and poke around in packets. And PacketBeat is doing the same thing. It's just easier for many systems to keep an overview of what is happening. So we have Wireshark running in the background here. By the way, let's say I want to have the last 30 minutes again and not the time frame I picked before. You could see, for example, here, thanks for all the requests. We can see the spike in the requests, what people have been doing. Since I have zoomed in a bit, this is hard to see, but we could, for example, see like how many MySQL queries did we have over time. And you can see in every 30-second time frame, we had like 2,000 or so requests here. If you scroll further down, you can see the height of the bar here is how many requests did we have, and the other is how long did they take. You can see response percentiles. So most of the response were pretty fast, but some took a little longer. Like here, the 99th percentile was almost 2 seconds, which is not that great anymore. You can see OK and error, and let's make OK green because it's always throwing me off. You can see most of our requests were OK, but every now and then we have some errors. Down here, you could see what errors did you have: TLS, DNS, or HTTP errors. Most of them were HTTP errors, and you could see like how many requests did you have and how long they took. Like one request took 22 seconds, and one here 6 seconds, but most of them were very fast. You could also dive into flows. This is basically TCPIP information, where you can just see like how many connections did we have, or web transactions where we basically parse what is happening. So you can see here, these were all the requests you were doing. And you can see here, most of them were 200s. When you added a user or you hit the base URL, you can see which response codes and which were the most requested URLs. How am I getting that information? I'm running PacketBeat in the background, but maybe when you've done your requests, that they were encrypted. It was HTTPS. So what I'm doing is I'm using Nginx as a reverse proxy, and then I'm handing over an HTTP request to my Java application. And I'm basically looking at that unencrypted traffic between the reverse proxy and the Java application. Otherwise, I wouldn't be able to get to that information. Because if it's encrypted, we cannot see it, but we're basically making use of that not encrypted traffic here. Speaking of Nginx, all the information that we have here, we could get from Nginx as well. And well, I've done that, so we have collected those. And here in the overview of FiveBit, what we have basically done is we've collected where all the requests are coming from. So here, this is my own data center. And I'm surprised we have that many requests from here. Also see wherever you're sitting, I can see here, we have from Portugal, for example, we have like 52 events. And we could, for example, on the one hand side, we can zoom down and see a bit more like where are people from and what are people requesting. So for example, that is probably Lisbon, if my geography is not wrong. And we could, for example, now just say like, hey, I just want the traffic from Portugal. And we could just filter down on that. That's more or less Portugal. Oh
yeah, we like a rectangle.
Yes, it's more like a rectangle. See, now we've just filtered down on those, and you can see over time, whoever is from Portugal, these were your requests. We can see how much traffic. I can also see which browsers you were using and which versions, because, well, that's all in the access logs that Nginx is collecting. And something that we figured out over time is that a lot of people are actually trying to collect Nginx access logs. So we use FiveBit, but we have a so-called FiveBit module. And all you need to do here is say, I want to monitor Nginx. Because we know on my operating system, Ubuntu, it's in var log Nginx access logs. And we know what the file looks like, so we can parse that automatically. You don't need to configure any parsing rules or anything. It's kind of a trick to avoid any unnecessary parsing. It's like logging to JSON. Some protocols that we know, like MySQL or Nginx or Postgres or Mongo, we can just collect those logs and work with them without doing anything in particular. We could also get the same thing for MySQL, but we could also get, for example, the metrics from MySQL. We're also getting metrics from Nginx, by the way. Let's see how that looks like. So if I head over to Nginx, we can get the metrics. And there we basically see how many requests did we have over time in Nginx on our reverse proxy. We could also see like how many requests were handled over time, reading and writing, and how many requests have been waiting. So you maybe need more threads for Nginx. All of that can just be collected. I'm almost disappointed that nobody started a denial of service attack against my service, because sometimes that happens, but it's okay. Even if it dies, we can still monitor what is going on. So that's
okay. Give me a sec. I'll try it right now.
Yeah. Good luck. One other thing that people sometimes try is, did anybody try to SSH into my boxes? Let's see. I'm collecting those as well. Just for the fun of it, let's say in the last 24 hours, you can see how many SSH login attempts were happening and were invalid, an error, or were accepted. This is me when I was logging in, but you could also see where are the SSH login attempts coming from, and which usernames were they using. So, for example, I'm surprised. Normally, it's either Russia or China.
Oh, you have some from China, so it's fine.
Yeah, I mean there are some, but not that many. Today it seems to be Canada. 20 requests from Canada. I'm kind of disappointed. Canada is such a friendly country.
Yeah, probably a Chinese guy went on vacation over there.
Yeah, or took over a server there, but that's kind of unusual. And you can see which usernames people were trying, and I'm really surprised that somebody tried butter as the username. I'm not really sure where that is coming from, but well, we can collect all of those and just see what is going on. Okay, so we've seen log files, we have seen pings to see that our service is up. We've seen metrics both for the system level, like CPU and memory. We've also seen metrics like JMX that we could collect, or we could also get metrics from Nginx, what we've just seen. We have seen network packets, where we basically just look at the headers and then know, okay, this was HTTP. Request response took 500 milliseconds, response code was at 200, and you asked for foobar. We've collected all of that. Something that I promised to show you was which usernames people were actually using. So let's quickly try another visualization. So the username that I was talking about is here, this one, where you could enter a name in the URL and we can show those. So what I'm doing here, I'm using MDC, the map diagnostic context, to just store structured information. Let's say this is like your username. If you were using Spring Security, this could be your username for logging in. I kept it simple. You just have something in the URL. We still want to log those and see like which usernames were people were using. Or with that MDC information, you could just say like, or if a user complains and says like, hey, this is my username, you could just look into the logs and say, just check all the logs for that specific user to see what they have been experiencing. So let's build another quick visualization because this is not built in. Let's say we want the horizontal bar chart, doesn't really matter. So we want FiveBit information, and we want to have the x-axis. I want to break that down on a term, and the term is that I think the field is called name, if I'm not mistaken. And let's say I want to see the top 15 names of the last, let's say the last hour. So we want the top 15 names in the last hour. So somebody called Carol was most active and did 107 requests. We can also see that David and Philip are kind of built in. Then we have Zika, Mika, we have a bot, we have other stuff, and we even see our emoji. I'm not sure if it was version 5 or 6, but at some point we added emojis through our entire stack because people really want to use emojis everywhere. And as you can see, we can log them and we can collect them and we can properly display them.
Of course.
Of course. I'm almost disappointed that nobody tried a scripting injection, because sometimes people try script alert 1 or something like that, but we escaped that. So this wouldn't help you. And also, we don't have any naughty messages, so that's good, because sometimes I got not so nice messages in here. But thanks everybody for behaving. Okay, one other thing that might be interesting is tracing. So you might have seen Jaeger or Zipkin. We have our own tracing agent for that as well. And that can just trace whatever is happening in your Java application. How do you add that? It's just a Java agent that you add to your existing jar file, for example. So here, let's say we have the front-end application. In my front-end application, I just pass in some configuration parameters. And this one is the tracing that we have. So we have our own Elastic APM Java tracing agent. We also have Go, Ruby, Python, Soon.NET, React, Node. I'm probably forgetting some, but we have a lot of tracing agents. What I'm doing here is I'm basically saying, here is my jar file that I just add as a Java agent. This is the front-end application. This is my own namespace. I want to trace methods happening in there. I want to trace every request. This is just some configuration. And then basically I say, this is the APM server where this should be sent. And I also ignore some stuff. For example, the health metrics and Jolokia endpoints. I don't want to trace those because that's I'm only interested in what users are doing and not what my automated pingers are doing. So I'm just collecting all of that, and then we have built-in visualizations for those traces. So you can see it automatically knows we have a front-end and a back-end application. Let's say I head over to the front-end application, and you can see I have some cron job that is generating some requests every full hour, so that's why we have some activity here. But now, since you got to the service, we got more and more requests here. So you can see here we have more HTTP requests, and we have also more 300s. I'm surprised we have so many 300s. And you can see which URLs were hit, how long did it take, what was the percentile, and like what is the request rate. And the impact is basically the more often something is called and the more slow something is, the more impact it will have on your entire application to be faster. So for example, we could look into add. Let's look what happens when we add. You can see these are some requests. So we had 100 requests to add something that was very fast, but we also had some slow requests. So here we have, let's go to that one request. Let's see what has happened here. Here we've added one user, so you basically see we added one user. Let's see this one here maybe. Let's say, yeah, this one looks better. So you can see here we called our front-end controller and the method add, and you could even click on that and just see what this method has been up to. But maybe add is not the best one to look at. So let's look at generate. Since this is the worst one, let's see what happens when we generate the user. These are really slow. And you can see it's still spinning because this one here has a lot of activity. Once it's finished loading, hopefully, let's head to that one. And if my browser makes it, we should have a full trace of seeing why this took like 600 seconds to load. But let's maybe try one that is a bit shorter, because 600 seconds might not be all that good. You can see my browser is probably almost crashing because, well, this is a lot of requests. Somebody called the generate, and they generated 1,000 users. And the ones here that are even slower, that are probably like millions of users. And maybe doing a call with 1 million users to be generated, that's not that great to show anymore. So in our timeline here, you can see we did some get operations. And if we scroll down further, at some point, maybe we also see some method from JDBC or not. It might be just too many requests to actually see what is going on in here. So you can basically see we called an add one to actually call the add to one specific user. This is what has been called in the background. You can see this was the request object and the response object. You can also see where is this running, which service is this using. If you had Spring Security, we could see a user, or we could even add custom tags. For those 27 requests here, let's jump over to those. You can see here they just generated one user probably. Let's see what other traces we have that might show us something. Let's say we want to see the add.
Well, are you able to trace individual method calls on the request and see, for instance, when you have
Yes.
like a chaining method call, that seeing that particular method, for instance, a JDBC statement is taking like X milliseconds of your total request because
Yes.
database is slow or something?
We can. I just need to find the right one where this is actually happening. Let me see.
Sure.
Here, for example, this supports distributed tracing, so you can see front-end service, back-end service. This got us a 500. This was when MySQL was down, so this is the error. Let's see, maybe these one have better calls. Or actually this one here, maybe. Since we had an error and people are generating random requests, it's sometimes a bit hard to predict what we will actually find in those traces. By the way, we could just switch over to the backend application, and there you can then see, for example, get all users. what queries we are running in there. So here you could see, okay, this span was too deep, so we dropped something because probably the requests asked for too much data, so it kind of dropped that. This is kind of unfortunate for that demo. But here, for example, you could see here, this is the actual SQL statement that we were running behind it. Depending on how well you structure your SQL statements, those will be very few or many. And you can see where you're spending your time basically here. And depending on which trace you want to have, you will then see which are the slowest ones, which are the fastest ones. These were probably timing out again. But here, if you have the add new person, depending on which request we have, you should see that there is an SQL statement somewhere in here. So for example, here we are actually tracing down to the method call. So you can see I have a person generator, that is my class, and these are the methods that we are calling. I've actually filtered those down to just my own namespace because it otherwise would be too much and you're probably not interested in finding those in Spring Boot. So I've configured that it's only showing me what it's doing here. And this is actually doing a lot of calls. And this is because our application code is not very good. You can see we're doing a select, an update, followed by another select. So we have this typical n+1 problem in our queries, followed by lots of other methods. And this is why your call is pretty slow. And here you could actually debug and see like what is calling what SQL statements are you running, and where are you spending your time. But you can basically see, okay, this the get toys method in marketing, which is mine, and then we have 51 more frames, but these are all from Spring Boot. So we didn't trace those in more detail. So you can see all of those. Something else that we can do here, by the way, is if we head to front end, for example, you can see the errors, which errors happened and how many times. So you can see this is indeed null, was our null stack trace, and you can see when did it happen, where, and how many times. So this is where you want to fix stuff, for example. And something else that you might be interested in is metrics. The metrics show you transactions and the requests, but they also show you how many errors occurred, CPU usage, and memory usage. This view doesn't include the JVM metrics yet. We are collecting those, but only the next version will actually be able to show you like the heap usage included here as well. But this is what this is all collecting and combining together. So these are all the errors that happened in our application. You can see how many times, when they happened, and what the actual error is. We're actually collecting them or grouping them by having this stack hash. So we're basically taking the stack trace, hashing it, and then we can see like this is one single stack trace that has been happening.
Wonderful. Hey, Philip, just to let you know, we're like 5 minutes away from your core time. It's been very interesting, and we have a couple of questions from our audience over here.
Yes, I think the one thing that is relevant is if you want to try this out, this is the code. Like all the configurations and samples are available there. That's probably the main thing. And I'm happy for any questions now. Let me stop sharing and let's head over to questions.
Wonderful. So we have a question from Bruno Batista. He's asking, what's the performance impact of the instrumentation in the normal process execution? By the way, you might want to remove your screen share because, yeah, I'm seeing myself duplicate.
Yes. Then you want to see yourself duplicate. Of metric beat or the APM?
I believe it was the tracing stuff.
So the tracing in APM, the general approach is that we have pretty much zero garbage collection, like everything will be allocated statically and we don't have continuous garbage collection. The colleagues are actually running a lot of benchmarks on like making sure this is very performant. I can post you the link afterwards. We have a very good post, like we had an Advent series, and one of the authors of the APM agent posted like where they're optimizing and where they're spending the time. Generally, it should be very minimal. You might want to enable that you don't collect 100% of the traces, but you have some sampling. So in my example, For the demo, I sampled 100%, but you might only sample like 1% of the calls, just to keep the overhead low.
Okay. And this question actually for me. So you were showing some of the tracing stuff that I really enjoyed. Are you also able to trace calls over microservice calls? So when you have like multiple microservices, are you able to trace all the REST calls and aggregate them into a single thing and make sure that you're able to trace that and check it out?
Does the distributed tracing? So you can trace it amongst different services. You can even trace it between languages, since all our clients use the same format, and we also have an open tracing bridge. We have sample applications where we trace between the Java application to Node, to Python, whatever, and you see all the REST calls between them. And we can generally dive into JDBC calls in Java and anything REST-based where we just keep the headers and then follow the trace along.
Wonderful. And now we have a question from Anas. So he's asking, so we're using Kibana/Bix. Do we still need to use Graylog or Grafana?
Well, you don't have to. Those are just alternatives. Graylog is a good logging solution, but I always call it the one-trick pony because it's just focused on logging. And as soon as you want to get to metrics or tracing or anything, you will need a different solution. Our approach is very much to have like one thing where you can see everything, and you don't have like many little islands, and you have one tool for metrics and one for health checks and one for tracing, and then you need to jump between them. But you can much more link between the different things that you have if you have just one tool like Kibana, and then you can stick to that tool. So that's our approach, and we try to keep everything closely related to make the most out of your data.
Okay, and then I have a question from Ilan. So which parts of the stack that you showed today are free, and which ones are paid for?
So I didn't show any paid features. The paid features would be alerting. So if you want to get an alert, if a 500 happens or a certain number of 500s, or if your heap usage is over a certain percentage or something like that, we do have alerting, which can send you emails, Slack, PagerDuty, SMS, whatever. That is a paid feature. If you're using our cloud service, that is included in the cloud service, but only our own cloud service. We also have a feature called anomaly detection. So we call it machine learning, but it's really anomaly detection. So it would basically learn what is the traffic pattern on your site, for example, or how many requests do you have, or how many people are putting something in the shopping cart, or how much revenue do you have at one point or like over time. And then it could determine anomalies that suddenly you have a spike in activity over the weekend, which might be an attacker, or you have an outage during the day when you have less traffic to your site. Those are paid features. Everything that I've shown here is free to use, and you can just go wild.
Wonderful. Okay, I think this is it for questions. I feel it. Thank you so much for this wonderful presentation. I think that people in the audience really enjoyed it. And they were really hooked into it. At least I was. And it was awesome to have you here on the VChat for the first time. And we hope that you can return in the future.
My pleasure. Yeah, I definitely have stuff to come back, so I will be in touch. If you have more questions, anybody, just send me something on Twitter, and I'll try to reply to whatever I have.
Wonderful.
Thanks for organizing.
Wonderful. Yeah. So thank you everyone for watching, and see you again on next VChat section. Bye-bye.
Bye.